Welcome to this Learning on Demand video. In this video, we are going to be looking at relative clauses. This is an example of a relative clause. The door, which was pulled off its hinges, was battered. The bit inside the commas is the relative clause, which uses a relative pronoun to add extra information about the noun. Have a look at this example in more detail. The door, which was pulled off its hinges, was battered. The door was battered is our main clause, which has been separated by the subject here. Which was pulled off its hinges is a relative clause, which commas have been used to show it in the sentence. Which is the relative pronoun, which links our subject to our relative clause. The main clause could still be a sentence by itself, as it makes sense. The door was battered. However, the second sentence is now the relative clause, which doesn't make any sense by itself, which was pulled off its hinges. The relative clause has to be stapled into the sentence with commas, a bit like a sandwich, and it only makes sense if the rest of the sentence, so it is relative to. A relative clause gives us extra information about the noun in the main clause. It is connected by the pronoun which. And relative clauses only start with relative adverbs, where, when or why, or relative pronouns such as that, who, whom, whose or which. This is the success criteria to be able to make your own sentences with relative clauses. You start with your noun, in our case the door, add the comma, add the relative pronoun, which was which, finish your clause, another comma, finish the sentence, and then check. By reading the sentence without the relative clause, you can check it makes sense, as the main clause works on its own still. The relative pronouns to help you here are who, which, whose, that, or where. In maths this week, our focus is on place value to 10 million, and you can see here a place value grid. The biggest column here is the millions column, and the smallest columns here is the ones. You can see in each column there are counters. This makes the number 3,168,213. We can represent numbers in lots of different ways. Here is our number again, 3,168,213. We can represent it in counters, or we could represent it as a part-whole model. This is still partitioning our number into the different place value columns. However, this time we are making sure we have the correct amount of zeros and digits for each part of the number. We can place our number on a number line. You can see here we have 3 million and 4 million, and because our number only has 100,000, it is closer to 3 million. We can also place our number into a bar model. Note that the bar model here shows the size of each part relative to the other digits in the number, unlike the part-whole model, but still partitions the number. We've also done some learning this week based on ordering and comparing numbers up to 1 million. You can see here two numbers in place value tables. 3,434,769, 5,267,891. The bigger number here is 5,267,891, and we know this because it has 5 millions compared to the smaller number which only has 3 millions. When we are ordering and comparing numbers, we begin by looking at the biggest place value column, and we work through the number if any digit is the same to be able to compare. This example demonstrates that further. Here we have three numbers, 1,334,790, 1,253,281, and 1,353,842. When we are comparing these, every number begins with 1 million, so we need to look at the next column, which is the hundred thousands. We can see here that the middle number only has 200 thousands, whereas the other numbers have 300 thousands. So this one, 1,253,281, is the smallest. When looking at the next two numbers, both have 3 in the hundred thousands column, so we need to look at the 10,000s columns. And we can see here the bottom number only has 5 10,000s, whereas the top number has 3 10,000s. So the bottom number is bigger, meaning that the top number comes next in our order. This leaves us with the final number, 1,353,842, as the biggest number.